All right, we had in lesson 6, I had a question about number 7. Number 7 wants us to find parametric equations for the line that passes through that point. So we have our reference point right there, and the midpoint of the line segment, we have 2 points here. So to find midpoint, that's the first step here. So step 1 is find midpoint. And for those that don't remember from their grade 9 course, or earlier in this course, midpoint, and I'll just refer to it as MP, is your x1 plus x2 over 2. So we're finding the average of each of the coordinates. 2, z1 plus z2 over 2. So our midpoint then will equal, so we have 2 plus 4 over 2, 3 plus the negative 1 over 2, and negative 2 plus 5 over 2, which means my midpoint will be 6 over 2 is 3, 1, and that's unfortunate. That's going to be a decimal, but negative 2, so it'll be 1.5. All right, so there is midpoint. So there's step 1, all taken care of for us. So I'm just going to group those together, shrink it so it's not taking up so much board. So step 2, we need to find a direction vector. So our direction vector. Now how do we get a direction vector here? Well, we have a reference point. So we have our reference point, and now we have another point on the line, so we can find our direction vector by simply taking our, I guess I'm going to call it reference point, so I'll put RP here, just so you can see where I'm getting it, minus midpoint. So that means I will have my reference point, 0, negative 1, 1, minus my midpoint, 3, 1, 1.5, which will give me a direction vector of negative 3, negative 2, and negative 0.5, or negative 1/2. So there's our direction vector. Now we have all the information we need to find a parametric equation. So our parametric equation, so step 3, parametric equation. So the equation of our line would be x equals our x coordinate. So it's a midpoint, 3 minus 3t. So that comes from my direction vector. All right, the y value would be 1 minus 2t. And finally, the last one is z equals 1.5 minus 0.5t. So that's how you would do question number 7. You got our parametric equation. So definitely need a point on the line, and you need a direction vector to plug into our formula. If you have any further questions, let me know, and I'll see if I can clarify them.